Okay, yeah, I got some sound there, and let me see who's with me here. Hi, Libby, glad to see you, and Lauren as well. So let's go ahead and get started. We'll be a few minutes early, but that's okay. And let me make sure I mute everybody, and glad to have you here. Now, today, we're going to take a look again at M&D chemicals, which is due on the 16th. And as well as PAR Inc. We took a look at PAR Inc. on Monday. I think we took a very, very brief look at M&D chemicals, and that's over in pages 52 through 57 in your textbook. And as the authors talk about, this is a simple, what they call minimization problem. Okay, and these folks make I guess they make products for bath soaps, laundry detergents, and as we scroll down here, we're going to see, okay, the decision variables, and then they walk us through the objective function. Here are the two decision variables. Here's the objective function, and then we see the constraints that are built in. Now, I'm going to go ahead and let's go over to the files over there in let's go to the files section, excuse me. Okay. And we're going to come down to the MS files that have all of the student files, the web files. These are the files we've been working with. I'll download that zip file. Okay. And then what you'll want to do is, I believe this is chapter 2 it's in, and we'll open up the Excel file, and there's M&D, and I'm gonna go ahead and open up M&D. And those of you who came in, we started about 3 or 4 minutes early, so no big deal. You can always double back and pick up where we were, pick up where we started. Now this is M&D chemicals, and again, I'm going to have you save this to your desktop on whatever device you're using. And I'm going to put a copy of M&D, and just for myself, just for kicks, I'll put Harmon, Keith. And so I've got it on my desktop to save as an Excel workbook. I will save it. Okay. And I'm going to diminish this down for a sec and go and see that it is indeed on my, I'll throw this over here real quickly and make sure that it is indeed on my desktop, and that it is. And when I'm finished, we'll upload. Now, I'm going to go ahead and expand back up here, and I want to just do some quick kind of housekeeping with everybody, keep everybody on tap. The syllabus, of course, is always a place where you can go to find all of the assignments in order. Let me do one other thing before I do that. Okay. In every class I teach, I put the virtual office hours that I have for those days. Today, they're virtual office hours. I have them set up to go from 5 o'clock to pardon me, it'd be 3 o'clock to 5:30. And that's the same as, I think, yeah, the same as I set up on Tuesday. So a virtual office hour is simple. You just click on that link, and I'll hear a chime if somebody comes in, and then we can, if you have a question, I can answer it, try to explain something, whatever. But I am there, and I am available, and I can do everything there, the remote, that I could do if I was just sitting in my office. So I want to make sure everyone is aware of that. We'll go back to the syllabus section for just a minute. Okay, and again, this shows us the work that's due this week. Okay, you have Nolan Plastics. Okay, and then chapter 1 and 2 are due. Okay, and I want to go, yeah, and I have, pardon me, Earth and Me. those, yeah, okay, I had those do the 12th, and then these two chapters do the 15th. That's strange. On the 16th, I've got PAR and Friday, PAR Inc. and M&D Chemicals. And okay, it was no. All right, I'm sorry, I'm mixing myself up. Okay, yeah. Well, let me show you what these are. Sometimes, just very candidly, you'll see stuff like this here. You may or may not. I sometimes have to make accommodations, and that's what you'll see when you see something like that. Let's go back over to the modules, and we'll scroll down here. And we are in module 2, which is 212, 214, 216. And M&D Chemicals is due Friday the 16th, as is PAR Inc. And then chapter 3 and 4. Okay, so we've got the M&D file. You have the M&D file open, and as the text speaks about, this is just a simple minimization problem. All right, and they begin to walk us through again the decision variables, and that is how many gallons of product A are we going to make, and how many gallons of product B. Now, this is a fairly, although it's a simple problem, it's an excellent model of the issue that process manufacturers run into, especially if they're what we call a batch producer. Let me explain what I mean. If you get off of 77 and you drive east there on what becomes MacArthur, okay, there's that gas station there, and over there, I believe it's a mobile facility. I believe it's either Phillips or Mobile, but it's a processing station, okay? And just like when people move electricity, they have to have transformers and et cetera. There's also a grid that goes with that pipeline, all right? And so when we talk about that batch processing, we're talking about these folks at M&D Chemical get materials, they produce a product, and that means that they have to dedicate certain pieces of their plant or their processing facility to one product, or have the capability to handle those, and then separately another one. Now, the authors don't go into that, but if it's a batch process, it means it will do a job. It'll produce a certain amount and then stop, maybe retool, etc. If it's what we call a continuous process operation, like the electricity is, or water, okay, those are systems that are on all the time, okay? And when they get overloaded, for example, if there's a blackout or your power flickers a little bit, when say you're in Oklahoma City in the summer, it means there's a heavy demand put on the grid at that time. Well, that being said, we see that we have a certain number of gallons of product A and product B. Then we have the objective function. Okay, this is the math behind this. And remember, in management science, we always look for a model. Okay, and be it a mathematical model, be it an iconic model, like say maybe a flow chart, or a graphic model, and then an iconic model, which might be a scale model of the real thing. Or you say we're developing a new fighter. They're going to make a plane and send the thing up with test pilots and see how it performs. So that's the authors are walking us through that process. Okay. Now they have 600 hours of available processing time, and then they add that constraint, and then they add non-negativity constraints. And what that means is we can't have a negative. We don't have a negative value in the constraint, because it would violate the assumption of a linear trend. Okay, and remember, a linear trend, that's the model. And when we run simplex, we're going to see that. So let me for a moment open this back up. And if you should have Solver on your machine. If you don't, again, you want to go over to click on options, and then you click add-ins. And if it's not in the active area, then you want to select it to be active. Obviously, I have it active in my machine. Now, I'm going to go back and I'm going to click data, and I'm going to click Solver. And let's take a look at, we'll look at this for just a minute. Okay. And we set the objective that's there in B17. And again, just to reinforce, Solver lets us decide, am I going to maximize, minimize, or have a target value? Okay. And those are really the three, those are really the continuums. That's really the continuum decisions. If you think of it like a continuum or a line, on one end would be the maximum, excuse me, my brain is not working. On the other side would be minimum. And somewhere in the middle or somewhere along that line segment, okay, of possible decisions, which then that line segment has infinite numbers of points. Okay, I have an optimal, a target. Okay, and that's why we're working with the simplex LP. I want to pop back over to the book for a minute. Okay, and you'll see this as we come down. We see the linear algebra that's been applied here for processing time and production. Okay, and you'll see as we look here on the horizontal axis, we've got the gallons of product A, and then on the vertical axis we have the gallons of product B, and so we have the abscissa and the ordinate. Okay, and we're computing points in space. Okay, and we're assuming that there's a linear trend as regards processing time. There's a linear trend as regards production, and that slope, that change, or that pathway, I guess, can be charted through that line. Okay, and now for my money statistic, this is really what we've computed here is a line of best fit, similar to what you get, say, with a linear regression. Okay, same thing here. The whole point of it, though, is to say, okay, what kind of problem am I working with? Well, I want to minimize. Okay, that's fair enough. What's my objective function? Here it is. I want to minimize my total cost. Okay, and then here are the variables I'm going to change. And those are over in B15 to C15. All right, and let's look at that. B15 and C15, those are the products, how much we're going to make. Okay, now up here in the assumptions area, well, really these are all assumptions areas except the output down here, but here's the output period. The rest of it's all assumptions. The difference is, we've got a minimum total production of 350 gallons, and a minimum in product A, a minimum of 125 gallons of product A. Okay, so you got to make 350 gallons. A minimum of those should be 125. So we want to find the lowest total cost. Okay, we want to minimize that, and we have constraints in terms of how much product we're going to make. Now, if you look up here at this matrix, you're going to see, we see that expressed. And then if you look down here to the constraints, you're going to see the constraints B20 and 21. Okay, and they cannot, and that figure must be equal to or greater than, that's the 125, that's the demand, so that's how much you got to produce. This must, on the left-hand side, this must be total production. You know, it's got to be 350. It's got to be equal to or greater than. And then we have the processing time, and notice this, the processing time must be equal to or less than 600. So we have the constraints. Then we tell them make unconstrained variables non-negative. So we're not going to have any negative variables. And then here we're choosing a solving method, and we're assuming it's a simplex. Now, I want to go back to the book for a moment and talk about this again. Management science is an eminently practical tool for a manager's toolbox. And people who, if you're getting a degree in management science, say a master's, okay, or operations research, okay, you're gonna dive into a whole lot of stuff in not far deeper water than this. But at the top, at the user end, it's very simple. It's a very simple concept, okay? And so we're building this model, all right? And what we're after is what's the feasible region, okay? What's the region where we're going to find the best response we can get, okay? And here it is. Here's the feasible region. That means we have a very narrow, very, very narrow set of possible choices. Although, theoretically, this is an infinite set. Well, it's finite in the sense that, you know, you have a line segment from here to here, but it's infinite in the sense that even that a line segment can have an infinite number of possibilities. And we're assuming that these data, because they're interval data, okay, that type of data, they're interval, they can be divided infinitely. 1/100th, 1/1000th, 1/10,000th, etc. Okay, it's like decimal places. Well, let's move over here to the next part of the text, and they talk about, they give us a summary of the graphical solution procedure. Now look, old school people will sit down and they'll do they'll do the linear algebra, okay, and then plug it in. The truth is, you know, it's a cool thing to see, and I guess if it helps keep your mind active, good enough. But why would you do that when you've got the machine to do the underlying computations? The key part here is not the math, it's the decision making. And I can't impress that enough on you. That's why I say management science is very esoteric, okay? But it's also of great practical importance, and that's why it's such a fascinating thing. Now, I've got a master's degree in production operations, and so I've been through those courses, and I can tell you, it's they push you pretty hard. But if you step back from it for a moment, think about, let's take the airlines. Even at this moment, thousands of airplanes above planet Earth, you know, thousands of them landing, taking off. And you know, if you make a mistake and you have an outbound in the same lane as an inbound, that's not good. And it's a very frightening experience. I had one of those at the university I worked at, the second place I worked. I was the dean of the College of Business, and the provost was a pilot. He had a small jet, and because I had grown up with my dad, and my dad had a pilot, and I had grown up in a little four-seater, and I could read maps and all that business, the provost had me sit up front. And I remember we were coming into Lambert Airfield, St. Louis, and we were coming into the runway, and what we saw, there was a commercial airliner making its taxi to go and depart, headed west east, pardon me, on that run. So we were coming into that runway. Well, every device and everything in his thing went off, and every alarm, and then he was on the thing, and he was able to divert. And I've never forgotten that. When I was working on that master's, and I had faculty member, and every course would say, this is very esoteric, but it's of great practical importance. Okay, so we can do really magical things if we use these skills that we've been given by the good Lord to depict these things. But you as a decision maker, okay, you have to be, the linear algebra is not the important piece. The important piece is, do I have the right information? Do I have information that I can verify? Okay, and so if I were going to use this as a model for production, and I'm going to say this over and over and over, I didn't just pull these out of my back pocket. I got them from somewhere. Okay, they're either going to be historical data of the company or industry standards. Okay, and sometimes they're just what I call raw realities. I have no data. I'm just kind of guessing. Okay, and we're going to see that. When I'm into that I'm kind of guessing mode, that's when I say to everybody, use some randomization and somehow simulate key variables and see what it looks like. The ability for you to go in and Excel and use the rand between, okay, or the random number function, it gives you the power to forecast possible outcomes. And my job and yours, okay, is to say, here's what's likely to happen if we do X, Y, and Z based on the information that we have. Okay, so now we're down to this point where we've got the constraints built. All right, and let's talk about this for just a moment, because as we look at this, we have a cost for each of these. Product B is more expensive, so I would assume it's maybe a premium product, who knows. And notice that we have to make at least 125 gallons. Now, the text will give us some verbiage about that. Okay? And then we want to start to talk about the issue of any surplus variables that may be in there. Okay? And here they give us the constraint. And are there any slack variables or surplus variables? And we'll see that you'll see that when you run solver. And then they walk you through, this is another practice problem. Okay? And then they show you the computer solution of the problem as per the book. And again, here we see, this is from that WEd file, that lingo tool that they use. But here's the variable, here are the values, okay, and of what we've produced. And we haven't reduced the cost any. Do we have a dual value? And yes, we do. For constraint 2, for every change in constraint 2, we add 4 units. For every change in constraint 3, we reduce by a unit. And then we can come in and we can see allowable increases. And notice this is like a mirror, 1 to 1, infinite to infinite. And that is, how much can we increase it? And then we see the constraints, and then any allowable decreases. Okay, and then for constraint 1, 2, and 3. And the authors are going to talk about some alternative solutions, those kinds of issues. And that's the par ink problem that we looked at. Well, let's look at this again. Now, what I'd ask you to do was to make some changes. Let me go back up here. And we'll go over to, okay, M&D chemicals, time permits. find the left-hand side and the right-hand side at the processing time. There you go. I'm just going to copy that and click home. And I'm going to insert a text box. And this is how I would work on it. So I know, and I'm just going to bring that up in terms of size so it's easy to see. Now, find the left-hand side and the right-hand side of processing time increases 10% per product, and the time available goes down 8%. All right? So let's look at this for a moment. Now, the left-hand side and the right-hand side show us basically the constraints. And all I can tell you is you're looking at these, basically these components of the line for the linear algebra that underlies this, or the simplex method. Okay? And here I'm asking us, okay, if processing time goes up 10%, let's come up here to processing time. Well, you have per product, you have 2 hours for product A and 1 hour for product B. So you increase that by 10%. And then the time available, you're going to have 92% of it, or minus 8%. Okay. Now, what I would do is I would set up, I would set up a label and then a value for each of these and run them, because we already have a solution on this. But let's see what happens if processing time goes up and the time available goes down. Now, I want you to notice something. If you look at this problem that I posed to you, this is very typical of these kinds of load balancing problems. So what do you mean? Well, if you look at it, the processing time, okay, that's getting ready to make this stuff, to process it, okay, that's going to be reduced, okay, and it comes at a cost. And then the time available goes down. And you say, well, how would that happen? Well, what we might find, and again, these folks are dealing with chemicals, okay? And one of the reasons I really enjoy teaching this course is because it lets me walk you through all kinds of different companies and all kinds of different businesses, 95% of which you'll never work in, but you might. And it's instructive for you to understand some of these internal dynamics that make the use of models so important. It may be that we find out that we get in a batch from a vendor, okay, and the stuff is not as good as it usually is, which means we have to process it longer, okay. And then we may find that we've just gotten a new customer, and so we have to cut the time available for every operation or every product line we have to accommodate a new line that we've acquired. Or this may be a rush order. So I've got to have it by so and so. Well, then how does that change things for us? And so that's the logic of why I'm asking you to do this, not just to give you something to piddle your time away or to mess around, but think about this when I give you these. What's it saying about the operations? What's going on? Okay, and take that into account. And it's pretty typical. There may be these things where, I have surplus time, where the time available, instead of decreasing by 8%, increases by 8%. Okay? And so this is telling us something about the conditions within M&D chemicals. And I don't remember if the text talks about them being a batch producer or what, to be honest with you. I mean, I really don't. And if they are, we'll go back to the textbook here for just a second. And we'll take a look at it and see if the authors tell us. They do look like a batch processor to me, just simply because they're working with a couple of products. Okay. Yeah, they're a batch producer. Okay. And that means that they do a job. They get some stuff in, make it on to the next job. People of all sorts call them because they mix and work with chemicals or those types of materials. Yeah, not a lot different than a lot of what we call assemblers, and they're manufacturers, but they assemble stuff. So they'll get parts and put them all together. Okay, or you'll get original equipment manufacturers that have multiple product lines. Okay, so we've got that problem to work with. Okay, and so you'll just need to plug in those variables and do some work with them. Now, I do want to go back over here for just a moment, all right, and talk about this key passage, all right, that shows you the summary of the graphical solution, okay? But a key piece of this is the verbiage and the speaking about the solution, okay? And what is it telling us? Interpreting that data. What is this telling us? Now, if I'm not mistaken, I'm pretty sure I'm not, I have some resources for you in addition to the textbook to help you understand what that's all about, to read the output and to look at it and to interpret it. Now, you have the textbook that will tell you, and that's important stuff, okay? On the same, by the same token, though, you need some other resources, and one of them is Excel Easy Solver. Okay, and I'm going to go over there, and this will walk you through different types of problems. Notice we have a transportation problem, also known as Northwest Corner. No, pardon me. This is the Northwest Corner method problem, a shortest path. An assignment problem, maximum flow, capital investment, sensitivity analysis. You can see there are all types of problems that this is useful for, okay? And they show you how to add it in all this business, all right? And they give you an example and show you the dialog box, adding constraints, all that business, okay? And then you'll want to also look at interpreting it, okay, and what they're talking about. Now, solving the model, and I have, in addition, I will go back here for just a second. I have some information about the GRG nonlinear and the evolutionary, and I'll probably, it probably would be to your benefit to go out, say, to YouTube or somewhere like that. Okay, be proactive about, you pay a lot of money to go to school here. Be proactive about this stuff, and don't just count on me to spoon feed you to find it. So let's go over here for a moment to YouTube, and I'll bet I'm going to find a bunch of videos. And I'm going to put MS Excel Solver reports. And you'll see here, for example, is a YouTube video on interpreting solver's sensitivity. Okay? And what is that all about? And then the solver reports interpreting. And they give you a nice little examples, 14, 15 minutes. And I would certainly encourage you to take a look at those. Okay? The solver and the reports. Again, those are going to be as good or better than what I'm going to be able to tell you or would tell you or what you'll see in the textbook. Okay, so I would really encourage you to take use and pardon me, make use of those resources. So that brings us, now to this issue, of M&D chemicals. All right, and some of the other things that we see here as we start to look at this, notice that the more expensive product B, takes less time to process. And you'll often see something like that because it's maybe a more refined version of product A. It's been more fine. It's more market ready, I guess would be a good term, or good production ready. All right, and then you have these constraints, okay, and that you've got to make a certain amount of product A, and you want to make a minimal 350 units. So you optimize that, and then you minimize your total cost. Okay. Now, when I do this, okay, I can also then, knowing the gallons produced, all right, and what I sell them for, what the costs are, that can give me a little bit of a look into my budgeting. All right. Now, out in the real world, if you did this, somewhere in this spreadsheet, you would also have the selling price per gallon, okay, for each product. All right. Now, you're gonna hear me say this over and over and over. We don't give you a pricing course, and we should. 95% of the business schools in this country don't give people a pricing course. They'll have pricing if you go get a master's in finance like I did, okay? And I had a pricing course. It's a shame we don't make you take a pricing course at the undergraduate level, because pricing, most companies foolishly set their prices according to internal budget needs. In other words, the revenue they'll need to operate the cash. When a price is a signal, a price is a piece of market data, just like a stock price, or the price for a car, or the price of a loaf of bread. And so if you really wanted to go beyond this, you could get you'd add pricing data. Then, okay, the revenue per unit. Then you can look at contribution margin. You can do break-even analysis. So this can be a great starting place to move you on to some of those other models that you want to use to look at this. Okay. And again, these are just, these cases are bare bones starts of what's going on. The wonderful thing about Solver is that it exists, because I guarantee you, working on linear problems, okay, it can be a lot of work, frankly. And if you make a mistake and then you go out and you try to implement it, you've got a problem. Or if you make a mistake on your math and you try to simulate the numbers, you have a problem. But with Solver, that stuff's taken care of. That's why they call it Solver. Okay, and it's exceptionally accurate. other than pivot table, in my opinion, it's the most powerful tool. Or the data pack, the data analysis tool pack. It's the most powerful tool that you possibly could have, and I like it because it allows you to build. This right here is a good start. If all of these data, okay, are good data, now I start to look at pricing, and now I can start to look at contribution margin. I can look at break-even units, break-even volume, and now I'm ready to think strategically because I have enough data and information to do that. And it may well be that you might have in some companies, when they launch a product or they decide to change pricing or something, you'll have a committee of people, maybe different disciplines, maybe a cross-cut, depending on the size of the company, or it might even be a small company and just the people that run it, okay, who've been there for years and know the customers and they know the lay of the land and how to handle all that. Okay, and this is just the first piece of this, because this is the production phase. Okay, we haven't even looked at the inbound optimization that would need to occur. Okay, or the outbound, the transportation problem. And transportation problems can be inbound; those are more like queuing problems, or then outbound. All right. And so all I can say is you have this incredibly simple tool to use, and yet you can get such powerful insights into what you're going to do with your business. And see, this is what will make you thinking like an owner. When you start to ask yourself when you're a manager, if we do this, one more person, we add one more person in payroll, if we add one more product, if we expand our plant, what's the impact? What's the most likely outcome that we'll get? What would be the optimal outcome? And that doesn't mean the perfect income. It means the one that I can work with given my constraints. Okay? And those are circumstances of a company, the history of a company, all kinds of things that go on. You say, well, we've talked a lot about this. Yes, because these models give us a gateway, if you will, or a doorway to walk into and look at the operations of a company and see it and think about it in some ways we may not normally perceive. Okay. Well, it's about 11:39 or 11:40. I started about 5 or 10 minutes early. Okay. And I think you've got enough on your plate this week to work with. So I'm going to go pop back up here for a moment. All right. And again, this week you have M&D Chemicals is due on the 16th. And then the PAR Incorporated is due the 16th as well. And then you have Chapter 3 and Chapter 4. Those are due on the 16th. And the 16th, of course, is Friday. Now, you'll see I have the M&D key and the PAR Inc. key. And Monday, I'll go over them and we'll talk about it a little bit. Okay. And then we'll shift our focus to Module 3. And we'll look. We'll review PAR, as I said, and then the wins materials. And we're going to be looking next week at Hewlett, okay, and PAR Inc. Continue, which exposes us. Lets us look at the Microsoft Excel sensitivity report. And then you'll have an exam over Chapter 5. So we're going to have the Hewlett and PAR Inc. continued. Those will be both due. And notice I have some more resources for you, okay, that start with a sensitivity analysis in Excel, and then different ways we use that, like shadow pricing. This is an efficient frontier if you're a finance major. and you're taking this course, you know all about the efficient frontier for a portfolio, and then modern portfolio theory and what that's all about. Okay, and it doesn't have to be stocks; it can be any range of assets that we want to build a portfolio with. Okay, you say, what do you mean? Well, if I'm FedEx, I have a portfolio of vehicle types ranging from large cargo jet planes down to vehicles that make short, hot runs from distribution points to terminus points. So I'm going to have to be looking at that portfolio of vehicles I have. Okay, conveyor equipment and plants and all that. So this gets you thinking. I hope you'll use some time to do some thinking about all of that. Well, folks, listen again. Thank you so much for your time. Glad to see you here. And if you came in a little bit late, you won't miss anything. You can look at what we did today, and we'll go from there. So I'm going to go ahead and stop the meeting. And before I do, does anybody have a question I could try to answer for you? Okay, I see no questions, so I'm going to stop the meeting, and then I'll record this, and once I've finished processing the recording, I will put the link to the YouTube video up here in the announcements. Okay, everybody, have a great week. I will see all of you on Monday.